Good evening, everybody.
Good evening.
Good evening, everybody.
Good evening,
All right. My name is Ray Andrade. I am a proud LMU alumnus who now serves this community as its programming librarian. And on behalf of the entire library staff, I wanted to welcome you to the semester's first installment of Faculty Pub Night. Thank you, everybody, for being here tonight. For tonight's event, we are going to be featuring Dr. Matthew Siniawski, from Associate Professor of Mechanical Engineering at the Seaver College of Science and Engineering. For tonight's presentation, he's going to be talking about service learning and engineering, design projects that promote inclusion and independence. However, before we begin the formal part of tonight's program, I did want to clarify a couple of things about Faculty Pub Night. So just to clarify, our series of Faculty Pub Nights are not for faculty only, that's number one, and because they're a pub night, I wanted to clarify that pub is a play on words. It means publication night. Okay? So it is not 21 and over only. So students, please tell your friends. All right? All right, so there's that. Also, I wanted to draw your attention to the feedback forms that are on your chairs. So if you please fill out those forms, not only do you tell us whether or not we're doing our job correctly, but you could also provide your email address and you would be automatically entered into a raffle for a $100 gift card from Amazon.com. All right, so there's that. And if you could please return those feedback forms to the plastic box to the left of the television, we would really appreciate that. Okay. All right, so now on with the formal part of the program. To formally introduce tonight's speaker, I would like to welcome Dr. Anthony Sabatino, Clinical Associate Professor and Director of Catholic School Leadership Programs here at Loyola Marymount University.
Good evening. Good evening. Forgive me, I normally would not stand at a podium. Let me read this first. Matthew Siniawski is an associate professor of mechanical engineering. He has advised over 40 different senior capstone project design teams since 2004 and is particularly interested in the design of assistive devices for children with disabilities. He has been the lead advisor since 2012 on various service learning projects in partnership with Wish Charter School, a local school dedicated to inclusion education. He is an active proponent of service learning and is interested in understanding how such experiences impact the technical and professional development of engineering students. He teaches various courses in engineering design and machine design, and is the lead faculty coordinator for the capstone design projects. Matt possesses a BSME from IIT in 2000 and a PhD in mechanical engineering from Northwestern University in 2004. Currently an associate professor in mechanical engineering, he has also served as an engineering consultant. Matt teaches various mechanical engineering undergraduate and graduate design courses and is, again, the lead technical project advisor for over 40 different mechanical engineering capstone projects. He's the principal investigator on 5 grants and research contracts, including 2 NSF grants. He's published over 40 journal articles, refereed conference proceedings, and industry reports, and magazine articles. He conducts research in engineering education, specifically in regards to service and service learning. So to finish the introduction and to do it very importantly, aside from the reading of one's bio, is to talk about the heart of the person. I'm not an engineer. I'm an educator. I have a background in school administration prior to coming to LMU. Was invited to attend Western Conversations, which is a gathering of the Jesuit universities and colleges of the West, where we have a topic to discover and to discuss in 2014. Matt and I are in the cohort. Matt and I met. This is new to me, Jesuit education. Trying to still define what does that mean at the university level. What does that mean for a university professor is new to me. So in attending Western Conversations, it was an exploration of mission integration. That was the theme for the 2.5 days. The provost from Gonzaga gave us our first talk. The president spoke to us at a dinner. Amazing opportunities for those of us who are finding our way in Jesuit education. And then I began to talk to Matt. And it became clear to me what Jesuit education is about. And so when they were talking about service, when they were talking about mission integration, I actually had the opportunity to be with someone who does that, who steps beside himself and knows what he is doing, as doing the right thing is important not only for the students that he's teaching, but the students that he's serving. And Wish Charter School is a school not very far from us here at this campus. It's a wonderful place that we call a place of inclusion, a place where kids are mainstream, a kids where people have an opportunity to have dignity. And Matt serves that dignity in leading the students that he brings to that school and helping them to understand how to serve that dignity as well. So at this time, I'd like to introduce, for this topic tonight, Matt Siniawski.
Thanks, Tony. I'm really honored to be here tonight and being asked to speak to everyone. I really appreciate everyone coming out tonight, especially on this gloomy Tuesday after we had Monday off. So yeah, I'm going to talk a little bit about the projects that we've been involved with for the past few years, specifically service learning projects that focus on the design of assistive devices, assistive technologies for kids with disabilities. So my talk tonight, I'm going to kind of focus on 3 different areas. The first part of my talk, I'm going to talk about how I got into these projects. I'll talk a little bit about some examples of some of these projects that we've been working on. Then I'm going to switch gears and talk a little bit about some of the research that I've been involved with in terms of engineering education. So, like Tony mentioned, one of my research areas involves engineering education. Specifically, I'm interested in how these projects impact our students, our engineering students here. And then I'll follow that up with a showing of a film that kind of encompasses these projects that we've worked on. So if people have seen that, I do apologize, but it's a short film, like 5 minutes, to kind of summarize. It's a really good kind of, words can't describe it, so I think it shows it better than I can sort of talk about this. So we'll conclude with that. So let's first talk about, again, how we kind of started doing these projects and sort of my story in terms of how I got to be involved with these and some examples of some of these projects we've worked on over the past few years. So let's back up a little bit. Again, I was brought to LMU specifically to teach design, to sort of run the senior capstone design courses for mechanical engineering students. And when I was here, they were typically paper-based design projects. And students really didn't get involved with building projects, building the prototypes. So one thing that I wanted to do was to include that. I wanted to have students building prototypes, testing them out. So we first started doing that in 2008. So this was a little while ago, and we started that with the Shell Eco Marathon competition. So it's a project that involves designing like a small little fuel-efficient vehicle, and they go to like a national competition and compete against other schools. So seeing that competition experience was really valuable, and these projects were very technically challenging, but really the students really got a lot out of these. So I really saw that these competitions, these projects were really beneficial. So we did that for about six years or so. We also recently started introducing the ASME Student Design Competition as an option for seniors. So this project is sponsored by ASME, that's the American Society for Mechanical Engineers. And they have an annual competition, and the scope of the competition changes every year. It's usually a little different. They mix it up. And so we've had students kind of competing in that the past probably 4 years or so. We also do industry-sponsored projects. So we have companies that we work with locally that provide a lot of mentorship to our undergraduate students. So some of the seniors are in here right now. They're working on projects with some of these companies, and there's a lot of value that comes in with having the students be directly connected with mentors from industry. So these are very valuable projects, and we've been working on these for the past 6 years or so as well. So I got an email in the summer of 2012 from an organization called RESNA, and I've never heard of this organization before, and it was a call for like a student design competition, and I was like, oh, this is kind of cool, I'll check it out. RESNA stands for the Rehabilitation Engineering and Assistive Technology Society of North America. It's a mouthful. Short for RESNA. So they have this is the premier organization, professional organization for physical therapists, biomedical industry, rehabilitation, assistive technology. So it's a really wide, diverse kind of group of people that are involved with this organization. So they have an annual student design competition. So they put out a call, I got the email, so I researched it a little bit more. I said, this is kind of interesting. So specifically, they have projects that they want to focus on mobility, so increased access for students, for people, so it's not limited to just children, as well as communication. So they have a really extensive website that you can go and take a look at all past entries for this competition to kind of get a flavor to observe what sort of projects they sort of are promoting. So right around the same time, I was like, this is kind of interesting because I was kind of interested in starting projects like this. So I said, all right, next academic year, this was 2012, 2013, we're going to do something with this. I'm going to have some teams work on something for this competition. In particular, I wanted them to partner with Wish Charter. So Tony mentioned Wish Charter, and that's the school where my kids are fortunate to go to. It's part of the LMU School of Family, or Family of Schools. It's a free, independent, public charter school here in Los Angeles. It's located right in Westchester here by Vons, if you're familiar with that area. So it's really close access for our students, which is great. And the main thing about Wish, the thing that we really are fortunate to be a part of, is that the center of their mission is really inclusion. So they have kids with disabilities that are just integrated into the classrooms. It's really well representative of general population, so there's about 10% of the kids there at Wish have disabilities, with a range of different needs. And the school was founded in 2010, and again, we're fortunate to be a founding family of that. My daughter, shown here, started there in kindergarten when the school started, and my son is there as well. And the school has just grown exponentially. Like there's a waiting list of 1,000 students to get in there every year, so it's a really great place. So anyway, we had two teams of senior students that worked with people at Wish Charter the following academic year. So I talked with the principal at Wish, Dr. Shauna Draxton, and I said, who could we work with there? And she said, oh, there's a couple students. There's one in particular is Jack. I believe he was in 2nd grade at the time here, and he has some physical needs that maybe you could help him out. So we had a team of students that worked with him, and they basically did some observation. They really got to know him pretty well, him and his family. He was supposed to be here tonight. I don't think they're here yet. But anyway, so they had a couple different ideas for some projects, and the one that they decided to do for their senior capstone project was basically a attachment for the stander that Jack used to use. So this gait trainer, it's sort of the supportive device that helps him stand up so that way he can independently kind of walk. Okay, so they saw that he uses this, but they thought that it'd be kind of cool and nice if he could have the option to ride a bicycle. So instead of building a separate tricycle, an assistive trike product, they thought, hey, let's integrate it to the stander maybe to see if he can use that. So the project was a success in the sense that our students came up with a product. They were able to test it out and physically go from conceptual design to physical reality with their idea. There were some challenges with this project that we weren't aware of when we started it, though, is that it turns out Jack really doesn't like the standard. He actually ended up stopped using it. So our students, the product, he was never really able to use it. It really wasn't something that he needed. Okay, and I'll get to that. This is an important learning lesson. This was the first project, one of the first projects we did with them. But the project, it was also a success in the sense that it established a connection with the Prime Engineering Company. They're the ones that manufacture that gate trainer. So we ended up doing another senior capstone project last year, I believe, in terms of they wanted us to kind of look at redesigning some of the components of that. So we looked at that. We had some seniors look at that. In addition to replacing some of the mechanical, like spring components, with some composites. So we had a graduate student that was looking at doing some analysis to see the feasibility of that. So it opened up some other doors. The other senior capstone project for that first year that we worked on these involved an iPad. They called it IDEA. So it was called the iPad Dexterity Enhancement Apparatus. And in particular, we worked with a student named Abby, and she was a kindergartner at the time, and she has cerebral palsy. And so she uses an iPad to help kind of communicate to others as well as to do her homework and stuff. So one of the challenges with Abby using that is that her arm kind of will drag across the screen, and she's not as she doesn't have the dexterity to really control that. So our students observed that, and they said, hey, we could maybe make something that can kind of help support her arm, so that way she could still move it, but it's sort of off the iPad. So they came up with this device, and they ended up entering that to the Resna competition. So both of these two teams did enter to that competition. This team actually got called back. So they were selected, they were one of the teams selected out of 6 nationwide to attend this conference. So they were one of the semifinalists, and they ended up placing 3rd in the country for their product, which was, to me, I was like, wow, this really validates what we're doing. I really think that there's something here. Let's continue working on these projects to get that recognition and just that sort of acceptance. So they went to that conference. Again, there were some problems with that product. So I'll talk about this a little bit later, but these products we're coming up with, they're not something that just takes a year to develop. So this was like the first prototype, alpha level prototype, very crude. Once the user's using it, we can kind of see what's wrong with it and fix that. So we had a graduate student for his design project, one of his projects. He redesigned that whole system to eliminate some binding issues we were having, because it's the way that this thing works is there's 2 like rails, and if things kind of are off, it will kind of get stuck and it'll bind. So we were having that problem. So she wasn't able to really use it as freely as we wanted. So he redesigned it. It's a little bit more robust, and it works a little bit smoother now. So we still have to follow up with her again to see if this is working, and if not, we'll try to address that. So with these 2 projects, again, I kind of alluded to some of these lessons that we learned. But number one, the main thing that I really saw is that it's really critical to work on projects that directly address high priority needs for these children. I don't want to work on something that might seem kind of interesting to some of our students, but really isn't useful to the students we're working with. Okay, so what I did was I created what I call a wish list. Appropriate, right? Being a wish. So I call it our wish list of needs. So I basically talked to the parents of some of these students. Hi, Abby.
Hi.
Some of these parents, I talked to the teachers, the principals, and I wanted them to start thinking, what do you guys need for your students? What do you need for your children to make their lives a little bit more easy, right? So some of this stuff could be for things at home. Some of these things are for when they're in the classroom at Wish. And so I have a list, a Google Doc that I shared with them. They can add to it at any time. If they come up with some idea, hey, let's write that down. They can email me. So I have this kind of running list of things that they need. And not only that, it helps me identify sort of what potential projects we want to work on, but also it helps me keep track of what things we need to follow up with. So, for example, the iPad dexterity device, it's on here. We're testing it currently. We still need to kind of follow up and make sure that things are working as intended. So that was the first lesson. The second lesson, again, I mentioned this, is that it really takes multiple years to get something that I think works well. And not to the detriment of our seniors, but they develop a product, they graduate and they move on. But sometimes the products don't necessarily function as we wanted, so we need to kind of continue and follow up. So it's a lot on me, which I love. I love being able to talk to them and be like, hey, is this thing working for you or not? Let's find out. If it's not, let's fix that. So sometimes we'll put a team on the same project the next year. Let's just redesign it. We have a base here. Let's see what we can improve. So that's kind of one of my thoughts with that. So once we've had this wish list, I was able to sort of come up with some low-tech project options for some students at some point. So we have this CERT program here. Most of you guys are aware of that. It's a summer research experience. And I had a lot of students coming to me. They wanted to work on projects. I said, all right, here, I have some of these low-tech projects you guys can work on. For example, this simple writing guide to help students kind of stay in the lines, as well as a sensory board that gives students different tactile and haptic feedback, just to kind of help stimulate them. So we had these different projects we worked on in the summer. These are currently being used at WISH. And then also based on that wish list too, we've had students working on these sorts of projects for their senior capstone since 2012. So quite a few years now. We've had students every year, at least one or two teams working on sorts of these projects. An example which we'll talk about later, we'll see a little video about this, like I mentioned, is we had a student team work on a portable desk stander for Jack. I talked to Ivy, Jack's mom. I said, what's the number one thing you need? If we're going to put some resources into this, I really want to address your top need. She said, I want something that we can take with us on vacation that would help Jack stand up. Not only that, but if you take a look here, he's standing at the same desk as his peers. He's not really excluded. So he's able to stand at the same table that his peers are standing. So that creates a sort of mental shift in him as well, that, hey, I'm part of this team. I'm not on some separate table next to them, but a little bit separate still. Another project we worked on was for Abby. Again, we worked on that project for the iPad device for her. So she was a little bit older last year, obviously. I think she was in 3rd grade. And Kelly, her mom, said the number one things that she wanted was a tricycle for her. And so some of these devices, these tricycles, are very expensive. And so I was like, well, let's put a team on it. You could obviously buy these, but our engineering students got a really valuable lesson out of going through and designing this and building this device. So let's put a team on this. And again, coming back to that follow-up, the importance of that following up with this, I talked to Kelly when I was picking up my kids from school last week, and I said, oh, how's the trike going? She's like, oh, I meant to tell you, that right now we're having some issue because when Abby rides it, she uses one hand pretty much, and so it will turn. And so I said, all right, well, let's get some team of students out there to help fix that, to make sure that it goes straight when she sort of lets go, or when we need to, right? Make sure it goes straight unless she's trying to turn. Okay. Some projects we're currently working on right now, and I have some of the seniors here, so they could actually answer some more technical questions about these projects if they come up. We have one student we're working with right now, Sammy. She's a 1st grader with cerebral palsy, and so this is a new student we're working with there, and she has a wheelchair, but this wheelchair is intended for people with spinal cord injuries, so it has this little footrest that her feet would sort of stay on. But the one project that our seniors are working on in particular is, in order for her to get in and out of this chair, she usually needs help from a paraprofessional, her mom, her dad, whatever. Okay, and then once she's standing, she's pretty strong and can stand for a long time unsupported, but just that transition, getting in and out of the chair, is something that they asked for. So I have 2 teams working in parallel on the same project, so a sort of internal little mini competition. So at least hopefully one of the projects is going to turn out to be good, right? But it's kind of cool because we get to see sort of different ideas come out from the students. So one team kind of came up with something that's a little bit more foldable, like using carbon composites to make it really lightweight. Another team is something that's expandable, so it kind of comes out a little bit. So this is going to allow Abby to sort of use her own strength to be able to stand up versus having to rely on someone else to help her do that. So again, I'm interested to see how this goes. And again, this is probably going to take a couple years to really get to something where I'm comfortable her having, The other project our seniors are working right now on is, again, this team is here. It's a lunch bench seat attachment, and basically, so when students at Wish, when they go eat lunch, they all sit at benches. For Abby, who has cerebral palsy, again, I mentioned her earlier, she usually has a seat that's sort of next to the bench. So she's not sitting at the same table or same bench necessarily, but next to them. So again, a little bit, there's a physical isolation, a physical barrier. So the teacher there and her mom said, you know what, it'd be really cool if she could sit at the same bench as her peers. So that's the project that we're working on right now, is how do we get her sitting at the same table as her peers. Because of that wish list that I had as well, last year I also teach freshmen Intro to Engineering course, and I thought it'd be a good idea to have our students partner with Wish last year in terms of like working on a real world project. So doing mousetrap cars or whatever we're going to do here in the lab is cool, and they could learn a lot from that. But I think having them work on a real world project out in the real world with real clients, it's a lot different of an experience. So that's what we did last year. A couple of the projects turned out to where they ended up working with students that had some physical needs. So one, for example, one team, they partnered with a class, and the teacher said that they really wanted them to come up with a fidget chair, they called it. So it was a real simple project. They basically modified a chair to put like one of those Bosu balls, sort of a squishy seat on it, so students can kind of fidget around and sit there still in the seat. Another project worked on a vision enhancement system for a student with visual impairments. I need to follow up with this project. I'm not sure if this was actually deployed yet. There were still some issues with like the Wi-Fi signals and all that, but that's a project that, I need to follow up on. So again, a couple of the projects last year worked on specifically assistive devices for these kids. This year, I thought it was a good idea to have all of my freshmen do that. The results were mixed. We had some teams turned out to be, they got something that was a good, I guess, physical product. And again, I sort of screened these projects. I picked projects that freshmen could handle, and some of them did. Some of them turned out to be a lot more complex than I thought. We had a couple projects. We had two teams working on sort of a seat support. So like the seat you're sitting in right now, someone with a physical disability might not be able to sit in that seat. There's an interest, there's a need for creating something that could just simply attach to that would allow them to sit in that same seat that their friends sit in. So that's that project. We have one of those that was, I think, finished. So we're going to hopefully be able to test that out. Again, very crude prototypes. Another one was a writing board. So you've all seen those like magnetic writing boards where you like Etch-a-Sketch type thing where you can slide across. So this one student uses something like that to write with, but it's sort of very elementary. He's older. It's not really cool to be carrying that baby toy around, right? So they wanted something that's a little bit more age appropriate. So this team came up with basically like a collapsible whiteboard, sort of, dry erase whiteboard. So it's about this small, folded up, and it expands out, and it has like a command chart. So if there's something, if he's hungry, he can just point to that. If he's thirsty, if he's got to use the bathroom, he can just point to those. So that's being tested right now. That was one of the projects that came out of this. A couple other projects, so these were all projects with Wish, and I've been talking with, I guess word's been spreading about these projects, and one of the directors of the special ed programs at chartered school for all of LAUSD got in touch with me and said, hey, there's students at other schools that have these too. I said, yeah, I know. But I like my little Westchester community bubble here. It's primarily for the easy access. Our students can basically walk to Wish. Okay, so if I have students across the district, freshmen, for example, they don't have cars. It's really it is a barrier. It's a challenge. Okay, so we had, again, I asked them, put together your wish list. What do you guys want? What do you need? Give me a contact there at the school. So there were a couple projects that we started this year as freshmen. One of them turned out to be pretty good. It was a sensory box for like a student probably with autism. She very descriptive in terms of what they needed, sort of playing with certain like locks and keys and stuff like that. So they have this little box that they made with light switches. There's a key lock there. There's a music box that on the side that you turn. So this is being tested right now. Again, I'm going to follow up with that. The other project on the right here was for KIPP schools, which is in Boyle Heights. I guess that there's a student there who's in 8th grade, and he has a wheelchair, and in order to get down to the play yard, they basically have to go way around, because there's like four or five steps. So they wanted a portable ramp. So being a charter school, they can't have anything permanent. They need to be able to take it down in case the district comes for inspection, because they share space with other schools. So we kind of, this project in particular was really challenging because we didn't have a contact there for until probably midway through that was really being reciprocative of our contact. So we finally found someone there that was really responding, and by that time we had our design, and once I shared that with them at the end of the semester, she was like, whoa, wait, this really isn't what we needed. We needed something portable, meaning we can take it down every night. So what they came up with was something portable that we could easily kind of, within an hour or so, go store it away, but it wasn't something that could be taken down every night. So there's ADA compliance, Americans for Disabilities Act, there's a certain steepness of the ramp. So right now we're sort of researching other options for them, but I'm not sure if we're going to be able to do what they need in terms of, because of that ADA sort of compliance. I'm not going to be able to use my engineering judgment and say, yeah, you know what, let's push it a little steeper here. So there's standards, let's make sure we're within safety. Okay, so that's sort of that dilemma with that project right now. And again, I'm always learning more about these sorts of projects as we're going, obviously. All right, so we'll switch gears a little bit. I'm going to talk a little bit about some of the research that I've been doing in regards to these projects. The first study that we did, I looked at the initial seniors, the 2 senior teams we had on the first year we were doing these sorts of projects. We had just a qualitative survey. We asked them at the end of the semester some questions. One, how did this project impact your development as a professional? How did it impact your development as a general member of society? What did you learn in regards to human needs, especially for those with disabilities? And then, did this project affect future plans that you have in terms of your career? So we had only, again, 8 participants there. We had 6 students respond, so very low numbers here, but at least it was just kind of a preliminary study here. We did an open coding approach to identify emergent categories in their responses. And again, this project here was done in collaboration with Vicki Graff in the School of Education, as well as Dr. Shauna Draxton, who's the principal at WISH. So they were both involved in this. So in terms of the first question we asked, how did this impact their development as a professional? We saw 4 emergent categories in terms of their responses. And on the left there, it sort of shows the ones on top were more frequently listed by the students. So the top thing that we saw in terms of this was improved teamwork skills. For example, they said they really thought that being able to communicate with people that don't have a technical background, they learned that, which was kind of interesting because they had to work with parents and teachers at schools, non-engineering people. Some other categories came up. I'm not going to show examples of these, but they thought they provided a preview of industry, improved communication skills, and some design training. So in terms of the second question here, how did the project impact their development as a member of society? We saw 2 kind of main categories that came up. The majority of students indicated that they saw an increased level of empathy within themselves. Here's some quotes here. I felt that my senior project made me much more aware of people with disabilities and simple things that we take for granted that they must overcome every day. This project opened my eyes to the hardships that many families go through on a daily basis, especially with rehab, which is really expensive and something that they don't really consider on a daily basis. Another student said, I learned to take a step back and look at it through the client's eyes, which is really important when working on human-centered design projects. Students also said that they felt empowered to address societal challenges. So the third question we asked was, what did you learn from your project in regards to human needs, especially for those with disabilities? Two things kind of came out of this. One in particular was that students really understood that human-centered needs, especially for those with disabilities, are complex and diverse. There's a wide range of those. Again, some tasks that we take for granted on a daily basis can be really challenging for people with disabilities. And again, some of these students have never experienced this and really thought about that before. Another quote says, "It made me realize that everyone has different needs in society. This project helped me balance those, helped us balance those needs." They also learned that some people, different disabilities, have different levels of that. So we worked with a couple students with cerebral palsy, and I've learned that too, that there's different levels, different extreme cases of cerebral palsy versus mild cases. They also learned too, they indicated here that they thought that assistive devices can be beneficial. There's a need for cheaper alternative devices, so a lot of these devices can be very expensive, so there's needs for devices that are more financially feasible for some of these families. So our fourth question we asked, the last question here, was we asked, how did this project affect your future plans? And out of the 6 students that responded, all of them indicated something in terms of they wanted to use their engineering career potentially to help others now, which was a kind of interesting result. So an example response from that, this project made me consider looking for an engineering job that has the primary goal of helping others. Another category was that they were significantly impacted by these projects. Majority of students said this. This project greatly impacted my career plans. I've been searching for an outlet to apply my engineering education toward the betterment of my community. This project was my favorite thing I worked on in college, was one of the biggest factors in my future career. Overall, extremely gratifying. I would rather do this project than the other ones. So again, all students have different sort of interests, but it was kind of really, obviously very impactful. So for these students that worked on this project, they seemed to get a lot out of it. Some students said that they're interested now in pursuing a related career. We had one of the women students that was working on this project ended up going to translational medicine, I think, to get her master's degree. So kind of a completely different path that maybe she wasn't exposed to before. All right, so that was one study. The second study I'm going to talk about, in particular, we did this, I think, last year. This focused on the first-year engineering students that we had working on these sort of service learning projects. We had a lot more students that we were able to survey, so we had 110 total, fairly decent response rate. We have a couple publications out in regards to this work, so Sandra Luca in the Dean's office, Dr. Pal and Dr. Saez were also involved in these studies. We did a mixed methods approach. That's basically when you have qualitative as well as quantitative research you're doing. So in terms of the quantitative stuff, we basically asked them, what is your confidence with different engineering skills? So we asked them before working on their projects as well as after their projects. And let me just back up too. So out of these 110 students, we had 2 sections of the Engineering 100 class that participated in service learning, 2 that didn't. So we call those sort of the traditional sort of course. The quantitative measure, we obviously do some literature search, and there are validated instruments that we base that measurement on. There were 24 skill questions. 12 of them we broke down into technical, and 12 were more kind of professional, meaning like communication, teamwork, things like that. So it's a simple sliding scale. So this was all electronic through Qualtrics. So they basically get this before the project, after the project. How confident are you in these different skills? And the students that were working on the service learning projects, we did expose them to human-centered design thinking methods. So design thinking came out of Stanford University. It really puts the user at the forefront of the design process. So the first step here in this process is empathize, really get to know your user, who you're working with. So these freshmen were exposed to this process, and this was the sort of design process we went with throughout the year with them. So in terms of what we saw, the students who participated in the service learning projects reported slightly higher gains in confidence than the students who participated in the traditional course. So the green here shows all the students from the Engineering 100. The red show the students that just did the service learning projects. Okay, so these were for all the students. And again, it was not huge difference here, but the thing that was really interesting that stood out to me was when we separated out the women. So when we looked at the women students, again, women are a minority in engineering. They're not the majority. Obviously, I think times are changing. We're getting more women into engineering now, but again, still, they're not the majority. But these projects had a much more significant impact on the women engineering students, which was really, again, kind of interesting to me. In particular, we saw the women that participated in the service learning projects had the highest gains in technical confidence out of anyone else across the board. They did have slightly lower confidence coming in than the males, than the men, which again, that's been studied. It's sort of, we know that. But the delta, the gains, the change that they had from pre to post was the most significant in terms of technical confidence for the women. We broke that down. Again, that was sort of the average for all those 12 technical skills I showed, pulling out some of the more, I guess, finite ones that we looked at that stood out. Understanding the stakeholder needs. Again, this was consistent. The women that participated in the service learning saw bigger gains in these areas. Generating multiple design concepts. Actually, constructing design prototypes was huge for this. So we really stressed building multiple, I call them quick and dirty prototypes. Build something quick so you can test it out before spending all this time on your analysis, on your very detailed design, and then all that time's wasted when you find out it really doesn't work. When you could just do a quick and dirty sort of test. So students were really kind of exposed to that. Okay, so in terms of the qualitative aspect, so again, I said this was a mixed methods approach. The qualitative aspect, we asked them at the end of the course, just pick two out of these 5 questions and sort of open-ended reflection prompts. They had to do with the first one was personal and professional development, 2, social impact, 3 was academic enhancement, how did the project impact your learning of engineering and design, some other ones. So again, we used an open coding approach to look at this data, and I'm going to focus on the third one there. Sorry, it should be a little bit more red. But the academic enhancement question in particular. So what did you learn about engineering design? Most of the students actually picked that question to respond to. Okay, so we're going to focus on that one. We saw a total of about seven different categories kind of came up in terms of what students indicated here. So things like problem solving, they understood that it's an iterative process with design, that at times things change, you have to go back. Teamwork, planning and management, stakeholder needs and design requirements, prototype testing, engineering mindset. This is kind of important, and this was kind of a category that was neat to me to kind of see, is that engineering kind of, being an engineer has a certain thinking process to it, like a logical process, so that kind of came up with one of these categories. So I'm going to focus on the one revolving around stakeholder needs and design requirements, because again, that came up with some of the skills that we were looking at. So there was a correlation here. We saw that the students who listed this category, the students that participated in the service learning much more frequently listed this, that they learned about understanding stakeholder needs and design requirements than the students that didn't, which makes sense. You have to really, again, understand what it is that the people need that we're working with. Okay, and again, we saw the bigger gains, especially with the women. So again, sort of consistent with what we saw earlier. Some of the student responses from that question, designing for the customers, what's most important, because as engineers, we're working for people in society. Including your clientele in the process is crucial. Again, empathy came up here. And again, I learned how to empathize with the client. Okay, so these 2 studies in general, sort of my conclusions with these studies here, I feel that these service learning projects positively impact our students. I think that we've seen, again, these results are preliminary, but they're sort of promising to me. Higher gains in confidence, in both technical and professional skills, especially women in terms of technical engineering skills and confidence. Students indicated that they learn how to empathize and understand stakeholder needs, which I think is a really important aspect of these projects. Students also indicated a desire to use their professional engineering knowledge to help others. So these were some of the kind of key general conclusions we saw. So now I'm going to switch gears. We'll wrap up with the film here. Again, this video was a collaborative project between School of Film and Television and the college. And I met Marilyn Becker, who's in School of Film and Television, at I believe it's like a faith and mission sort of meeting. And we just started talking. We're like, hey, we should do something together. So I was on sabbatical this year. So Dr. Nader Sinai actually took over and advised the senior capstone student team that year. They put together a great product. And so this film, too, was actually entered for the ASWE, American Society for Engineering Education, inaugural film festival last year, and they ended up winning for best film. So it's an award-winning film. So again, if you've seen this, I apologize, but we'll go ahead and show this now. Can you guys dim the lights maybe a little bit?
I could hear his voice shaking, and he said, I feel like our son's world is growing darker by the minute. I'm Ivy Steinberg, and I'm the mother of Jack Steinberg. I would not trade this child for any child in the world. We actually adopted Jack at birth, and I was the first one to hold him. I cut the umbilical cord, and at his 6-month checkup is when his doctor said, you know, I don't like the way his eyes are tracking. So, in turn, we took him to Children's Hospital and found out that he had something called optic nerve hypoplasia. And as far as Jack's legs go, it's a disconnect of the brain trying to communicate to the rest of the body what it needs to do. One of the things that's so important for Jack is that he's standing. And the reason why is because the Achilles tendons start to shorten through time if they sit too much. And that requires surgery. Jack attends a school called Charter, and the amazing parents there are so much a part of the school. One of those parents, Dr. Siniawski, is the engineering professor at LMU. And he came to us and he said, what do you need? What would make Jack's world better? So I said, you know what would be really great? And we use a stander for Jack to be able to stand, but it's not even a traditional medical stander. It's a walker locked down with weights on it so he doesn't tip over, but we can't really move it around very easily. So they said, we'll do it. We'll go ahead and work something up. So he put his engineering students on this, and we're beyond thrilled.
We're making this device specifically for him. So if he were to just go out and purchase a device and use it, those are mass-produced, and they make those devices for a general condition, whereas what we're designing is specifically for Jack. Every one of our requirements we have listed to meet his specific needs. Here we have a 3D model of the Mobi S stander. This assembly features 2 rotating clamps attached to the main channel. The clamps can be attached to a variety of surfaces using 2 knobs. The main channel houses all of the components in the assembly. Located in the left and right side channels are the pivot pieces. The pivot pieces house the vertical extension bars, which allow the system to be adjusted in height as the user grows. Attached to the vertical extension bars are the side pads, which can be adjusted inward and outward for a specified waist size. As an added safety feature, a back bar is attached to the system through the vertical extension bars. When the stander is not in use, it can be folded down for easy transport by Jack and his family.
There is no limit to what he can do, and he knows that. It's one of those things that now that I see him being able to have these gains and get where he wants to be, it's exactly what you want for your child, what anybody wants for their child. You want them to reach their full potential every time he reaches a milestone. It's just, as a mother, it takes your breath away. It just does. If I hadn't connected with the engineers, Jack would still be locked down to that walker, locked in place, until he's able to walk around on his own. His world is going to change with this device. You know, I have a feeling we're going to see him doing things that we hadn't anticipated because he will be mentally thinking, I am standing.
That was a great project, and again, I was only involved in setting them up. I wasn't involved in technically advising any of that. Oh, where's my seat again?
I could hear.
And I know that there's a need for more of these devices at Wish, and every time I see Ivy, Jack's mom, like on Facebook with a picture of Jack and he's in the standard, it makes me really happy that he's still using this. And I know, you know, she takes it to and from school every day. You know, like she brings it there, so he has it at school and brings it home with him. So again, one of my goals is to get some more of these made, you know, because there is a need for this. Yeah, so we had one of the students, Taylor, you saw her talk. She actually stayed on here for her master's, and we actually had her for her master's project, not a thesis, but for a project, she redesigned that product to make it a lot more manufacturable, because obviously that was just sort of a quick prototype where a lot of it was machining versus something, if you're going to mass produce these, it's not going to be made like that. So she took a step further to make it a little bit more streamlined. Again, we're kind of waiting to maybe make some more of those soon. So, all right. So just to kind of wrap things up, again, I think these projects have had a positive impact on not only the students with the disabilities at Wish that we've been working with and the LAUSD, but also on the students and the faculty myself. I know that these are projects that I'm personally very interested in. I'm going to continue working on these throughout my career here. And again, I think they really, I haven't mentioned this, but I think they do live the Jesuit mission here in terms of what LMU is about, you know, especially with service to others, and that's sort of what I think is attractive to these projects. So thanks for your time, and if there's any questions, I'll be happy to take some after I get a beer. Yeah.
So what's the upshot? Are you going to have enough students, enough time to help people at other LAUSD schools? What do you think?
I would like to. It's just, it is challenging for logistics. I would love to be able to work on these projects over the summer, for example. Like they have these RAU programs with NSF. I would love to be able to have students, say, from throughout the country coming here too to do this, because I think we have a unique situation here, especially with Wish, with this partnership with Wish. And working on these sorts of projects too, I've really learned over the years that it really takes a lot of time to invest in a partnership like that. It's not, again, like you can come in and out in a year or 2 years. It really takes 4 or 5 years of a relationship building sort of process to go through these. So I'm very hesitant to branch out to other schools, because again, my time and my resources, our resources here is limited. So again, I kind of saw that with the LAUSD projects this year. We tried them out. Again, I want to kind of continue working with that, but I don't want to expand out too fast, if that makes sense.
It does make sense. I can see, and I'm sure it was such an advantage right from the get-go, being a parent at that school.
Right.
Yeah, that's great. Well, I think what you're doing is fantastic. in every way.
I have some of my students here too, so if you want to ask them questions.
Could you introduce them?
You guys want to stand up and go ahead and introduce yourselves?
So tell us what you worked on. What did you work on?
I'm Mitch. I work on the lunch bench seat attachment for Abby.
I'm Sonia. We're on the same group.
Yeah, Anita.
David.
I have a question for them.
Yeah.
So what is the most challenging aspect from your point of view? I mean, it seems like it's a very complex project. Like, what did you find the most challenging?
For this, the most challenging part was actually getting it to be secured on the bench. We went through a few different ideas as far as springs, turnbuckles, and whatnot. Eventually, actually, Nina came up with just a simple knob and a little connection piece on the other end of the frame where you just slip it right in and tighten it as you please. So the two frames are connected by rollers. They can be disconnected if you need to, but so it can be adjusted for any size bench. So, you know, you take it to lunch, you take it to the park, you can go anywhere with it. You can put it on any size bench, put it on and tighten it as tight as you need it. Just with a simple, just little turn right underneath right here, and it tightens it up real nice. Other than that, everything went rather smoothly.
Once we figured out like the main frame.
Exactly.
Well, they haven't built that yet. So.
Yeah.
This is true.
We'll figure out more about that.
Through the design,
That's a design
that was the design issue. Yeah. So we'll see. But as of now, everything's pretty set. So hopefully we'll start ordering our parts this week and start manufacturing it. So.
Yeah. I guess another issue we had is we needed to find a chair that was appropriate for because she has cerebral palsy, so it needed to have the correct supports for her. And
Be comfortable. Too.
Yeah, and comfortable as well, and fit with our design. And that ended up being more difficult than we thought it would. We had to. So far, we've ordered 3 different types of chairs till we found one that worked with our design and fit under the table. And so that was a little bit of a challenge too.
I guess that would be another part of it was the height of it, the room we have between the bench. You know, these pre-made tables, the tabletop and the bench top, you only have about 8 3/4 inches to work with. So to design a frame with the turntable, I know you saw in the design, our turntable rotates and locks 90 degrees, so she can get in it easily. Has a little pin you pull out and they can turn. They put her in it and they can rotate it back. But to design a frame with a chair on top of it, within 8 3/4 inches was a big challenge for us. So we went through a few iterations of stock diameters or stock widths and reducing them and redesigning to try and reduce that width. And that came with the chairs as well. The first one we ordered didn't work. Second order was too big, so we ordered a smaller one. So that was another big challenge we went through.
So this team's doing really well. And then there's another team too back there. Let you guys introduce yourselves real quick. They're working on the stand transitioner.
I'm Riddy. We're on the same team.
Hi, I'm Justine.
And I'm Juan.
So what's been challenging for you guys?
Well, I think that it's just trying to meet exactly what Sammy, the girl with cerebral palsy that we're working with, needs. When we were given the project, we were told that it was just going to be a transitioning device to help her go from sitting in her wheelchair to standing. But when we finally met her, they said the biggest problem was actually her balancing as she's going through the transition. So instead of just like a mechanical device that we had to make, we had to include like a type of harness or something that would help her balance at the same time. And that was something that we didn't like know going into it. So like going through the process of finding out exactly what they want instead of like just what we were assigned was something to take into consideration.
Cherry, I see you back there. Do you want to say hi? Stand up. So Cherry worked on, she was one of the freshmen last year that worked on the fidget chair project. Yeah.
In terms of the actual fabrication of the device, the students develop themselves? Do they work partially with the machinist, or what sort of technique is used? I mean, do they have machine shop skills, or?
A little bit of both. So we have a part-time machinist here, so he'll help out. Sometimes the students themselves will machine some parts. This year we're a little overwhelmed. We have 55 seniors. Normally we have maybe like 30. So our machine shop is going to be really busy. So I'm having our students outsource a lot of these projects this year because of the fact that just the sheer numbers we have. But traditionally, a lot of these projects that we've worked on, the students really are involved with the whole process. Yeah, that's ideal. Ideally, they would be involved. It's just a matter of resources here, though. Yeah. Other questions? Yeah.
Are the needs at a place like Wish all mechanical, or are any of them electrical, and have you thought of branching out to the electrical engineering?
That's a good question. There are other needs too. So I'm mechanical engineering, and so that's sort of what I've been focusing on. But yeah, there are other electronic-based needs there. There's app-based needs. So I've been trying to talk with the computer science and the electrical engineering people here as well. So yeah, there's definitely a lot more we can be doing. Yeah, Jamie.
So you mentioned that that at least one of the students from one of the first cohorts had gone on to get a master's degree and kind of switched her focus completely, go into medical assistive devices or medical engineering. Have there been any of the other students from the original cohort who did end up kind of following that path as they sort of indicated that they might in the feedback that they gave?
That's a good question. I'm not sure in terms of follow-up, because some of these students, they have these ambitions, but yeah,
the market
they've got to start getting jobs. So not all the students will be able to do that, but in terms of the one I know for sure, she did go on to that program, but I'd be interested to follow up. I know a couple of the students pretty well. I mean, via like Facebook, but I should follow up with them and find out what they're doing. Yeah. So yeah, there's a lot more research I'd like to do too in terms of this area. You know, so.
Okay, if there aren't any more questions from the audience. Actually, I have one comment, not a question for you, Pat, but one thing that I wanted to share is that given the popularity of the Faculty Pub Night series now, we actually implemented an application process to select our speakers. And I cannot forget how during the selection process, the library outreach committee, when we were reviewing applications, it was an immediate home run with everybody at the table when we saw that application, because obviously how meaningful the program is. And I just wanted to say that your presentation presented something that was really far beyond how meaningful I imagined the presentation was going to be. So congratulations, Steve, Madam. Congratulations.
Hi, I just cannot believe that not only did everything in the film expand Jack's life in a way that you cannot even imagine, but today in the mail I got his report card. Now there is research done about how important it is that to get the maximum brain flow that children be moving. So somebody like my son who spends so much time in a wheelchair, it's really important that he's standing and moving and that his physical being is helping his brain to be able to do his schoolwork. So being able to stand in this device at school as well as at home, well, at school, he has a 4.0. Wow.
I wanted to thank Dr. Matt Siniawski. I wanted to thank Dr. Anthony Sabatino for the gracious introduction for today's program. I want to thank my library outreach teammates, Carol, John, and Matt, for running today's event. And finally, I want to thank everybody in the audience for coming in tonight. Thank you very much. There's plenty of food and drinks still at the back of the room. And if you can, feedback forms go in here. Again, thank you, everybody.
Thank you.